What is up? Welcome back to another episode of How to Algebra. In this video, I'm going to show you how to utilize the factor theorem. If you haven't done so, hit the subscribe button, like, comment, tell me what you think, and let's get it. All right, so the factor theorem, right? It basically says that a polynomial f of x has a factor of x minus k if and only if the function value at k is equal to 0. If you've seen the other synthetic division video or the long division video, dividing polynomials, right? When you divide the polynomial, if the remainder is 0, well, then we know that that's a factor, right? That is a root, which is basically a factor. And it's where the graph crosses the x-axis, right? It's the solution or the root or the 0 of the polynomial. So here, the factor theorem, what the factor theorem is saying is basically that when you use synthetic division or long division, whichever method you want, when you get a 0, right? When you get a 0 as the remainder, then that is a factor, right? That root is a factor. So let's see an idea. So the idea is that in basic division, if I divide 32 by 8, right? 8 being the divisor and 32 being the dividend, whatever answer is going to come out, that's the quotient. That's pretty standard. Like, we already know this. But just to demonstrate, 8 goes into 32 4 times. 4 times 8 is 32. We get a remainder 0. So this means that 8 is a factor of 32. Right, but we already knew this. If we try it, let's say a different number. So 8 into, say, 33. Well, 8 definitely goes at most 4, 32, with a remainder of 1. So because it's a remainder of 1, 8 is not a factor. And we can say that 33 is equal to the quotient times the divisor. So 4 times 8 plus the remainder, which is 1. That's really all we're saying. So give some colors to look at. So the quotient, right? Quotient times the divisor plus the remainder. Equals the dividend. Okay, so we can write our answers like this, basically. All right, so let's see the first example. We have a couple, so it shouldn't take long. All right, number 1. For x cubed plus 5x squared plus 5x minus 2, is x plus 2 a factor? That's the question. Well, we know that we can turn the factor, like if we set it equal to 0, we'll get x is equal to negative 2. And this is the value that we're going to put into the synthetic division box. Right, and then we grab all the coefficients. So the coefficients meaning make sure that they're all in order, right? X cubed, x squared, x. So they're all there, plus the constant. So the coefficients are going to be 1, 5, 5, and -2. Okay, and so the process goes, I bring down the 1. So here we multiply. I'll draw the first couple arrows to demonstrate what I'm doing, and then it'll go quickly. So I multiply, and I write that number here. So this is going to be -2. All right, and then we add going down. So 5 minus 2 is going to be +3. And then you rinse and repeat the cycle over until you get to the remainder. All right. I'm not going to draw the arrows now. I'm just going to do it. So -2 times 3 is -6. -6 plus 5, -1. -2 times -1, +2. And when we add, we get 0. So this means because we got a 0, this implies that, yes, it is a factor. Right? X plus 2 is a factor, 100%. Now, if we wanted, we could find the other zeros if there were other zeros. But I think for the purpose of this video, we can leave it at that, right? Is this a factor? Yes, it is a factor. Mainly because the remainder was 0. Okay. I guess one thing to note for future references, because this was a cubed, you can rewrite, or not rewrite, but add, right, x squared. So I guess let's go full circle. So this would be x plus 2, right? That's the divisor, times the quotient. So in this case, x squared plus 3x minus 1. And this is equal to the given polynomial, right? X cubed plus 5x squared plus 5x minus 2. All right, number 2. So for 2x cubed plus 5x squared minus 9x plus 20, is x plus 4 a factor? Well, let's see. I take the opposite of the factor, right? So x is equal to -4. -4 is what we're going to put in our synthetic division box. So -4. I grab the coefficients, so I first check to see if they're all here. 3, 2, 1. They are. So I grab the coefficients 2, 5, -9, 20. All right, and we start our synthetic division process. I bring down the 2. Again, I'll just draw the lines on the first iteration. -4 times 2 is -8. I'll write that here. And then we add going down. So -8 plus 5, -3. Then we start the process all over again. So -4 times -3, that's going to be +12 plus 9, -9. We're going to get +3. Times -4 is going to be -12. So the remainder is going to be 8. Okay, because this is different from 0, right? It's not 0. This tells us that, no, it's not a factor. And now when we write our answer, we know that because originally it was a cube, this is going to be a degree less. So x squared, x plus 3. So we write the divisor, x plus 4, times the quotient, 2x squared minus 3x plus 33. And then we add the remainder. This is going to be plus Okay, number 3. Given polynomial f of x and a factor of f of x, so that right there, them telling us that it's a factor, I know that when I do synthetic division, I should get a 0. And then we want to factor f of x completely. Okay, so the factor is x plus 2. So that means the root is going to be x minus 2. And then we just grab the coefficients. So we first check to see. So x5, we're good. x4. Notice there's no x3 and there's no x squared. So we're going to have to compensate and put zeros so to hold the place. So we're grabbing the coefficients. We have 16, 32, and then 0, 0 for x cubed, x squared, -1, -2. Okay. Start the process. I bring down the 16 times -2, -32. When we add going down, we get 0. Times -2 is 0, plus 0 is 0. Times -2 is 0, plus 0 is 0. Times -2 is 0, plus -1, we get -1. Times -2 is +2. So when we add, we get 0. And this was expected, right? This was expected, because they told us that it was a factor. Okay, so what this means is, because this was degree 5, that the quotient, this part here in the bottom, is going to be a degree less. So x to the 4th -1, basically, because I don't care about these zeros anymore. This is, right, it's all plus, and they basically go away. So what we have, 16 x to the 4th -1. Okay, we need to factor this completely. One idea that I have is that a difference of squares is going to be the way to go. So the idea is that if I have something squared minus something else squared, I can just take the a and the b simply and write a plus b and a minus b. But you have to be able to see it, right? Like, I need something squared minus something else squared. So the first thing I recognize is that 1 squared is really 1. Or technically 1 can be written as 1 squared. Okay, I need to somehow turn 16x to the 4th into a base with a square. 16 can be rewritten as 2 to the 4th, then x to the 4th, right? No change there, minus 1 squared. Okay, the 4th power on both the 2 and the x can, in a sense, be factored out in a way, right? So this means that 2x to the 4th minus 1 squared, right? Because if you think going backwards, if I apply the 4th to each of these, the 2 and the x, I get the line above. So this can be done. Okay, but I need it to be squared. So we can use exponent properties that a power raised to a power, you multiply. So basically, I want a power of 2. So 2 times what will give me 4? And the answer is 2. So what I'm saying is that this can be rewritten as (2x squared). And now the part in red, this is my a value that we're looking for up here. Right? This is my a value. minus 1 squared. So A is going to be 2x squared. B is going to be 1. So we put it all together. I'm going to get 2x squared for my A, and then plus 1 minus 1 for B. Okay, and then the last step, right? The last step is to see, can we factor it again? Like, can we keep this difference of squares idea going? Because we want to keep it going until we can't go anymore. So there's no such thing as as a sum of squares, right? So this first factor, this one's pretty much done. So we're just going to put a pin in it. The second one, however, this is again is a difference of squares, because 1 squared okay. Slight little adjustment. Okay. The parentheses mean things, right? Because it's 2x, that quantity squared. Okay. So then that means that, again, this is the A, 2x, not including the square this time. And 1 is B. So we can rewrite it. 2x and then 1. Again, plus and minus. Okay. So these two can't be factored anymore. So let's put it all together. Our factors are going to be x plus 2, because that's what was given. The first boxed answer, which should be in parentheses. All right, if we apply the square to both the 2 and the x, we should get 4x squared plus 1. And then the 2 that we found. 2x plus 1, 2x minus 1. Okay, now I guess a natural question would be, do you have to notice a difference of squares? No, not necessarily. You don't have to notice anything, right? You could factor this however you want, but a difference of squares is by far the most efficient. Thinking forward, you don't have it under your belt yet, but you could technically, in theory, choose another possible route and then do synthetic division again, which we'll get to that in another video. But for the purpose of this video, this is it. This is the way. Okay, last example. I always feel like the last example is the most challenging. So we want to find the remaining zeros. So they're telling us right away that -2 is a 0 and 3 is a 0. So when I do synthetic division, I will 100% get a remainder of 0 for both of these numbers. If I don't, then I did something wrong. So let's see. Let's first check and make sure everything is in descending order. 4, 3, 2, 1. Yep, and they're all there. So I'm going to start with -2. Could I start with 3? Sure. But I'm choosing -2. Right? I do what I want. So -2. Grab the coefficients. This is going to be 4, -3, -24, -7, -6. All right, we start the synthetic division process. I bring down the 4. Right, 2 times 4, I write that here. It's going to be -8. We add going down. That's going to be -9, 10, 11. -11. Times -2 is positive 22 plus -24 going to be -2 times -2, +4, add -7 will give us -3 times -2, +6. Okay, plus -6 is 0. And that was exactly expected. Right? That's what was supposed to happen. Because it's a 0, right? Because it's a 0. Okay, now, since they gave us 2 zeros, we're going to keep the party going. So 3, right? We're going to synthetic division again. We just keep it moving. This is going to be, bring the 4 down. So 3 times 4, 12, plus -11, 1, times 3, plus -2, +1, times 3, plus -3 is 0. Again, expected, right? It's just confirming what we already know. We really haven't gotten to the crux of this problem. Well, we're here now. So this means that because this was a 4th degree polynomial starting out, when we decrease it by 1, I know that this was x cubed. Then we have to decrease it by 1 again. So this is going to be x squared. So 4x squared plus 1x plus 1, since both the ones were positive. So to find the remaining zeros, we have 4x squared plus 1x plus 1. Do we have to write the plus 1x? No, it's just plus x. Okay, so we want to factor this. So let's think. Think about it. Always check to see if you can factor this by looking at it. So I'm looking at it. I'm thinking, okay, let's bring the 4 over, right? Because the AC method or slide and divide method, whichever method, factoring method you like, is going to come in handy right now. So 4 times 1 is 4. Multiples of 4 that add up to 1. So 1 and 4, 2 and 2. Okay, so neither one of these work. So at this moment, we only have one resort, and it's the last resort, and it's the quadratic formula. So quadratic formula says -b plus or minus b squared minus 4ac all over 2a. Right, this is the go-to. We probably could have started here, but you always want to check to see if you can factor it first, right? Because we're supposed to be nice at factoring. Okay, so we just plug in the values that we know. So 4 is going to be a, 1 is going to be b, c is going to be 1. Or b is 1, c is 1, a is 4. Okay, -b, so -1, plus or minus 1 squared minus 4 times 4 times 1 all over 2 times 4. All right, so simplifying, we get, what do we get? We get -1 plus or minus 1 squared, which is 1, minus 4 times 4, 16. So 1 minus 15. 1 minus 16, which is 15. Negative. So -15. All over 8. Okay. We're at the answer right now. It's mate and 1, for those that play chess. So the solution is -1 plus or minus root 15 I, right, because of the negative that's inside the square root. So this is a complex number for sure, all over 8. So it's a complex number, right? That means it's not a real root. It doesn't cross the x-axis. So putting it all together, right? Putting it all together, because it's a 4th degree polynomial, we know that it has at most 4 roots, whether they're real or not. I know it has at most 4. It was guaranteed to have 4, which we'll talk about that later. But fourth degree definitely has 4. Since they gave us 2 zeros that were real roots, right? Because the remainder was 0. The remaining 2 are complex, which we just found. So this is the factor theorem. All right, so if you found this video useful, please like, comment, hit the subscribe button if you haven't done so already, and I will catch you in the next video.